Hello, hello, my name is John Lennon. Look, if you don't know that reference, don't worry about it. But if you do, +1 on the social scale for you. Okay, sorry, I thought I could do chapter 2B into two parts, into one part. I can't, so I have to make it into two parts. Okay, and in this case here, we're looking at temperature, and we're going to work our way through. We talked about thermodynamics, how energy is moving and changing, and while energy doesn't get created or destroyed, it certainly does change form, and we talked about that in that previous video. Here, we're looking at temperature scales most often used in chemistry. We use Celsius and the Kelvin. Now, the Kelvin scale is the basic metric unit of temperature that we use. We don't use Fahrenheit. We don't. It is part of the English system. It is just not practical for us. Whereas in the Celsius scale, 0 is freezing point of water, 100 is the boiling point of water itself. And that works out pretty nicely. However, what if we are dealing with things that go into the negative, the below 0? Because there's a lot of things out there that don't freeze at 0 degrees Celsius. And you know, you stop and think about the air that we breathe in. Thank God. Okay, so it has to have a freezing point below 0. And that means we would have a negative Celsius. How did we handle that? Well, there was some English dude named Lord Kelvin who came up with the idea of the Kelvin scale. And we're going to get into that in a few minutes. But the thing is, okay, so now we got this Kelvin thing here, and now our negative Celsius is no longer negative because in the Kelvin scale, it's in fact going to be positive. So what's up with that? Well, that's when we get into the third law of thermodynamics. It is impossible to reach absolute 0. Now, in 2015, they did try at the Massachusetts Institute of Technology, MIT, they did successfully cool molecules in a gas of sodium potassium to a temperature of 500 times 10 to the -9th kelvins. And it is expected to exhibit an exotic state of matter by cooling these molecules a bit further. In plain English, real Chem, real fast. The colder it got, the closer it got to 0 Kelvin, the stuff started to act a little weird, okay? And we're not talking about, you know, some celebrity weird. We're just talking about, man, it's doing things we don't have an explanation for. We just don't. So anyways, but that's just the awesomeness of science, okay? So let's talk about calories and kilocalories here. Now those, you could look at those as energy units, and especially in our society today, where people are trying to be calorie conscious because of their health, which is understandable, but what is a calorie? What does it really mean? So a calorie is how much heat is needed to change the temperature of 1 gram of water 1 degree Celsius. A kilocalorie, otherwise known as kcal, not to be confused with kcal9. That is a television station that just happened to have the same 4 call letters. But a kcal, it is the kilocalorie. It's 1,000 of these type of calories. Now, a kilocalorie is equal to 1,000 times these calories here, which is equal to 1 calorie. You'd say, wait a minute, Canu, but it's the same thing, right? No. Notice this is the big C, and this is the little c. So there are 3 kinds of calories. You got kilocalorie, which is pretty straightforward. You have your regular calorie, which is the small c. Then you have your big C calorie. That is the calorie you see on your sodas. That's what you see on your food when they actually tell you, oh my gosh, if you sit there and eat that triple Big Mac at Mickey D's, you're going to get 4,000 calories in you. That's not 4,000 of these, guys. It's 4,000 of these. So I'm just showing this to you guys. Okay? All right. Son of the gun. We do need to move on here into chapter 2C, or not to see. That is the question. Let's see how much time we got here. And you know what? I'm going to stop it here. And we'll call it for chapter 2B or not to be. That is the question. Catch you on the flip side.